Hello friends, Mr. Burrell here. We're in Unit 5, and in our second lesson, 5.2, we're kind of extending our discussion about simplifying radicals. We're going to extend that discussion to talk about cube roots. We're going to talk about a couple other things in here, but we're going to focus our discussion around simplifying radicals that are cube roots. If you don't know what that is or what that means, we'll be talking about it in just a bit here. So by the end of this lesson, these are the things that I hope that you are able to do. I want you to be able to simplify cube roots using prime factorization and simplify cube roots containing numbers and variables. So notice these objectives look very similar to the objectives we had for simplifying square roots, except now they're going to be cube roots. Okay, we'll talk about what the difference is and how we go about solving those. So, how do we simplify cube roots? Radicals with an index of 3. So I mentioned when we were introducing this unit, we talked about a radical. This symbol right here is a radical, which most of us remember calling it a square root, which is correct when there is no number on the outside here. So if I have that radical symbol, that root symbol, with a number like a 3, I call that number an index. That's going to change the function of that radical symbol. So when I was trying to find a square root, for example, like the square root of 4, I was finding a number, another number, that when multiplied by itself 2 times gave me 4. So that's why the square root of 4 was 2, because 2 times 2 was equal to 4. Okay. Well, when we're calculating the cube root of a number, we are just finding another number that when multiplied by itself 3 times is equal to the original number. So for example, over here I have the cube root of 8. The cube root of 8 is 2, because 2 times 2 times 2 is equal to 8. The cube root of 27 is 3, because 3 times 3 times 3 is 27. The cube root of 64 is 4. The cube root of 125 is 5. The cube root of 216 is 6, because 6 times 6 times 6, 3 times is going to give me 216. So that is the definition of a cube root. We talked about square roots, where I'm looking for 2 numbers. Cube root is 3 numbers. You could do like a 4th root, where you're looking for another number that when it's multiplied by itself 4 times would give me that original number. We could do a 5th root or a 6th root. A cube root, that index of 3 is as far as we're going to go in this unit, but know that that can keep going. It can keep extending on forever and ever and ever. So when we're simplifying cube roots, we're looking for numbers that when multiplied by itself 3 times will give me the number underneath the radical. Okay, so we follow the same basic processes solving cube roots as we did solving square roots. So do you remember number prison? Remember me talking about number prison? This little radical symbol is my number prison. And the only difference between cube root number prison and square root number prison is this is just a higher security prison situation. Higher security, greater risk. So I'm going to start to simplify this radical by finding the prime factors of 54. So for example, 54 I could break down into 27 times 2. 27 I could break down into 9 times 3. 9 I could break down into 3 times 3. And that's as far as I could go there. So if I write that all underneath my cube root number prison, if I write all my prime factors underneath my cube root number prison, I get 3 times 3 times 3 times 2. Nothing different in the process so far. So now, what I want you to notice is that in a cube root number prison, this number out here tells me how many people need to be in a group in order to escape. So in the square root number prison, you needed to escape in pairs, remember, and only one survived. In cube root number prison, you need to escape in groups of 3, or in trios. So in a cube root number prison, you need to escape in trios, in groups of 3. This number out here. Well, when these groups of 3 try to escape, guess how many are going to survive? Only one. Only one survives in every group of 3. So if I have 3 3s here, only one of them is going to get out. The other 2 are going to get stuck in, I don't know, an electric fence or something. They're not going to make it. So the cube root of 54, this 3 gets out. This 2 didn't even have a group to escape with, so he's left on the inside. I'm left with 3 times the cube root of 2. Okay? So same exact process as we were doing with square roots, except now instead of escaping in groups of 2, you have to escape in groups of 3. Let's look at 40. 40 is 20 times 2. 20 is 5 times 4. 4 is 2 times 2. So if I write all those prime factors under my cube root number prison, I get 5 times 2 times 2 times 2. 5 times 2 times 2 times 2. Remember, I always try to write my factors in decreasing order from biggest to smallest. Well, notice here I have a group of 3 2s, so they can try to escape, but only one survives. So this 2 gets out, and this 5 stays inside the number prison. He's lonely. He has no group to escape with. So 2 times the cube root of 5 is the simplified radical form of the cube root of 40, and 3 times the cube root of 2 is the simplified radical form of the cube root of 54. Okay. Okay, so riddle me this. We're going to find the cube root of these numbers. I'm going to start over in this column. These are some simple ones. The cube root of 1, what's the cube root of 1? Well, I'm trying to find a number that when multiplied by itself 3 times gives me 1. 1 times 1 times 1 is 1. So the cube root of 1 is just equal to 1. What's the cube root of 8? We talked about this one on a previous slide. The cube root of 8, well, 8 is equal to 2 times 2 times 2. So the cube root of 8 is 2, a number that when multiplied by itself 3 times. Well, what about these? What about the cube root of negative 1 and negative 8? Can I do that? Can I find the cube root of a negative number? You've probably been told in the past that you're unable to find the square root of a negative number. And we're actually going to talk about this a little bit later in this lesson. But what about the cube root of a negative number? Is there a number that when multiplied by itself 3 times would give me negative 1? Well, riddle me this. How about negative 1 times negative 1 times negative 1? Well, negative 1 times negative 1 is a positive 1, times another negative 1 is indeed negative 1. So negative 1 multiplied by itself 3 times will give me negative 1. What about negative 8? This one might make a little bit more sense. Let's try negative 2. If I multiply negative 2 by itself 3 times, will I get negative 8? So negative 2 times negative 2 is a positive 4, times a negative 2. A positive times a negative is a negative 8. Indeed. So I can take the cube root of a negative number. The cube root of a negative number is just going to be negative. Okay, so we're going to do an example like that in a minute, but it's just going to be negative. So let me do a couple of these. So let's do like 640, for example. We'll do a positive one and a negative one. If I factor down 640, and you can always use your calculator to help yourself find some of these factors, but I'm going to say 64 times 10. 10 is 5 times 2. 64 is 8 times 8. 8 is 4 times 2. 8 is 4 times 2. 4 is 2 times 2. 4 is 2 times 2. This one has lots and lots of prime factors. So if I write all of those prime factors underneath the cube root number prison, I have 1 5, and I have 1, 2, 3, 4, 5, 6, 7 2s. 1, 2, 3, 4, 5, 6, 7. And remember, they have to escape in trios, so there's 3 2s here, 3 2s here. Only one survives in each trio. So this 2 and this 2 get out, and what do these numbers do when they get out of number prison? They multiply, so 2 times 2 is 4. And on the inside of the square root, I'm still stuck with a 5 and a 2. What are they going to do? They're going to multiply. So I have 4 times the cube root of 10. If if I were to type both of these in my calculator, I would indeed get the same answer. Let's look at this negative one. Negative 405. Let's break this down. This one, I might actually need a calculator too. So if I divide that by 5, I'm going to treat this as a positive number at first, and I'll show you why in just a bit. So I'm going to have 5 times 81. And 81 is 9 times 9. 9 is 3 times 3. 9 is 3 times 3. So I'm going to write my little cube root number prison. Here are my prime factors. And then I'm going to put underneath the cube root also a negative 1. So this is 5 times 3 times 3 times 3 times 3. And in order to make it negative, I'm going to multiply by negative 1. Okay? Well, in order to escape, they have to escape in groups of 3. So there's 3 3s here. Only one's going to survive. So this 1 3 is going to get out of the prison. This negative 1, because he's negative, he almost has like a free pass. That negative 1 is going to be able to come straight out of the cube root. Remember that the cube root of a negative number is still a negative number. So this negative is going to multiply on the outside. So this is going to become a negative 3. So he's good. He's all done. Then left underneath the cube root, I have 5 and 3. What are they going to do? They're going to multiply. So the cube root of negative 405 is negative 3 times the cube root of 15. Negative 3 times the cube root of 15. Okay. Let's go on to the next section here. So I want you to just give it a thought for a minute. We're going to talk about this in a minute. But why is the cube root of a negative number a real number, like another negative number? But the square root, we're going to talk about this in a minute. Why is the square root something different? We're going to talk about how it's called an imaginary number. Be thinking to yourself, why I can take the cube root of a negative number, but not always the square root of a negative number. Be thinking about that. So now that I've been talking about cube roots for a minute, what if I throw in some variables? What if I throw in some x's? Well, again, the process is going to be exactly the same. So the cube root of x cubed is really the cube root of x times x times x. Just because they're x's doesn't mean the rules don't apply to them. In order to escape from this number prison, they still have to escape in trios. Okay? So they're going to have to escape in trios, and only one of them will survive. So this x gets out, and there's no one left in prison, so I don't even have to write it. The cube root of x cubed is x. What about the cube root of x to the 5th? Well, that's the cube root of x times x times x times x times x. There's 5 of them. It takes 3 to escape. These 2 in a square root number prison would be able to escape, but in a cube root number prison, they can't. They're stuck. And then in this group of 3, only one survives. Only one escapes. So I have x times the cube root of, what do I do with the numbers left in prison? They multiply, so x times x is x squared. So the cube root of x to the 5th is x times the cube root of x squared. This 3 is applying to the radical here. Okay, so let's do a couple with numbers and variables. So for example, let's do this one. The cube root of 189 times y to the 4th times z to the 5th. Well, 189, let's see. I could write 189 as 63 times 3. 63 I could write as 9 times 7. 9 I could write as 3 times 3. Okay, so there are my prime factors. Let me write all the factors underneath the cube root number prison. So I'm going to write 7 times 3 times 3 times 3 times 4 y's and times 5 z's. It's a lot. There's a lot going on in this prison. Well, in order to escape, they have to escape in trios. Yeah, and they all have to be the same in order to escape. So only one of these 3's is going to get out, one of these y's is going to get out, one of these z's is going to get out. So on the outside of the number prison, I'm going to have 3 times y times z, because whoever gets out of number prison, they're going to multiply. And then left underneath the cube root, I'm going to have 7 times y times z, which is going to give me 7 3yz squared. 3yz on the outside times the cube root of 7yz squared on the inside. Okay? And I'll leave these ones for you to do, for you to practice on your own. But that's the idea behind simplifying cube roots, or radicals with an index of 3. Same process as simplifying square roots, except now I have to escape in groups of 3. So let me show you kind of a real-world situation where we would apply cube roots. So Alamo, or the Astor Place cube, is a sculpture in Manhattan. This is in New York, on Manhattan Island. It has a volume of approximately 16 cubic meters. I mean, look how big this is in comparison to this lady here. It's a pretty big structure. So let me kind of redraw this little cube. So here's the Astor Place cube. A cube means that all the sides are the same length. So this side, like this side, the length, the width, and the depth of this cube are all the same size. So if the volume is 16 cubic meters, what is the length of one of the sides of this sculpture? Write in simplified radical form. Well, volume of a cube is length times width times height, or x times x times x, or in other words, x cubed. Well, if I want to know the length of one of these sides, I can undo this cubed with a cube root. If I cube root the volume, it will tell me what the length of one of the sides is. Well, the cube root of 16, let me go ahead and write that in simplified radical form. Let me find its prime factors. 4 times 4, 2 times 2, 2 times 2. So that's the cube root of 2 times 2 times 2 times 2. Well, in a cube root number prison, you have to escape in groups of 3, but only one survives. So I am left with 2 on the outside of the cube root and 2 on the inside of the cube root. So 2 times the cube root of 2, that's going to be the length of one of these sides. That ends up being, let me see, it ends up being like a little over 2.5 meters. Each one of these sides is about 2.5 meters. That's pretty big. Okay. One last thing we're going to cover at the end of this lesson. Think to yourself, since you might not have a partner, can you think of a number that when multiplied by itself will equal -1? Or what about a number when multiplied by itself will equal -4? Or a number multiplied by itself that will equal -9 or something like that? Can you think of a number that when multiplied by itself will equal some negative number? Multiplied by itself 2 times. So, like when we were talking about a number multiplied by itself 3 times, like -1 times -1 times -1, or -2 times -2 times -2, if I multiplied those together, this still gave me -1. This gave me -8. -3 times -3 times -3 is equal to a -27. When I was multiplying a negative by itself 3 times, I still got a negative. Well, what can I multiply by itself just twice to give me a negative? Let's try with -4. What if I took -2 times -2? Well, that gives me a +4, so that's not going to work. What happens if I take +2 times +2? Well, that gives me a +4 as well. I could do like -2 times +2. That would give me -4, but that's not the same number. One's positive and one's negative. So in the real numbers, if you remember what real numbers are, they're like numbers, anything that can be written as a decimal or a fraction. All of those are considered real numbers. There is not a real number that I can multiply by itself that would give me a negative. Okay, there's not one. So how do I do this then? You've probably been told before that you can't. Take the square root of a negative number. But something we're going to be discussing in upcoming lessons. If the square root of a negative number can't be a real number, what we're going to start talking about is how the square root of a negative number is going to give me an imaginary number. The square root of a negative number is going to be an imaginary number. This is something you may have not heard before. In the number world, we have real numbers, so those are like numbers like 4 or -7, or 1/2 or pi. Things like that are all real numbers. Imaginary numbers, I denote an imaginary number with an I. And I get an imaginary number when I square root a negative. So like, for example, the square root of -1 is I. The square root of -1 is I. By definition, when I multiply an imaginary number by an imaginary number, like I times I, that's going to give me -1. So the square root of a negative number is an imaginary number. So let me show you this. If I take the square root of -4, well, I could write that as the square root of 2 times 2 times -1. Well, in a square root number prison, they have to escape in pairs. So 2 and 2, 1 escapes, and I get 2 on the outside. The square root of -1 is I. So I'm going to go ahead and multiply by I here. So the square root of -4 would be 2I. Okay, that's how I'm going to denote an imaginary number, by writing an I for imaginary. So like, for example, the square root of -72, if I break that down into its prime factors, looking at positive 72, I get 36 times 2, 6 times 6, 2 times 3, 2 times 3. Writing underneath my number prison, I get 3 times 3 times 2 times 2 times 2 times -1. In a square root number prison, numbers have to escape in pairs. So a 3 and a 2 get out, which multiply to make 6. This 2 stays in. And this -1, the square root of -1, can get out, escape, as an imaginary number. So I multiply by an I. So this would be 6I times the square root of 2. So, when I cube root a negative number, I get a negative number. When I square root a negative number, I get an imaginary number. So we're going to continue to talk about these. We're going to start talking about imaginary numbers. But that's it for this lesson. Hopefully you're able to simplify cube roots containing numbers and variables, and hopefully you're starting to understand, we're going to cover it more, the concept of an imaginary number. So that's all I have for you today. If you have any questions, please don't hesitate to reach out to me. Please let me know. I hope that was helpful, and I hope that you enjoyed it as much as I did.